Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 8-1 lesson on arithmetic sequences and series. In this one, we will find nth terms for arithmetic sequences, and we will also find the sums of arithmetic series. As a real-life application, we're going to figure out the cost of a phone call. For your warm-up, let's say we're given the sequence 2, 5, 8, 11, ... Find the next three numbers for the sequence, and then say how you found the numbers. Pause the video, give it a shot. So we notice here that we're adding 3 each time, so the next three numbers then would be 14, 17, and 20. So adding 3 is the rule for this one. All right, pause the video again and see if you can figure out the 10th term for this sequence. And if you're feeling really ambitious, go ahead and then find the 52nd term, and see if you can do this efficiently without adding 3 52 times. So if we want the 10th term, we're starting with 2, and each time we're adding 3. This takes care of term 1, and then term 2 would just be 2 plus 3. In order to get term 10, we have to add 3 not once, but 9 times. 9 times because 2 is already the first term. So we've got 2 plus 3 times 9, that's 2 plus 27, equals 29. If you want the 52nd term, then again you're starting with 2, and you're adding 3, not 9 times now, but another 51 times. So we need to do 2 plus 3 times 51. And that's going to be, let's see, 155. If we multiply all that out and add it. Pause the video one more time and see if you can figure out a formula for the nth term. See if you can find the pattern here. So you might have noticed on each of these problems that whatever term you're looking for, you're just doing 2 plus 3 times 1 less than that number. Because again, this 2 is already taking care of term number 1. So to get the nth term then, you're going to need the 2 plus 3 times n minus 1, whatever n is. The sequence that we were just looking at was an example of an arithmetic sequence. An arithmetic sequence is one in which the numbers have a common difference, which we will call d. So this is going to follow a linear pattern. You just keep adding the same thing every single time you take one more step into the pattern. And there's 2 different formulas we're going to use. If we already know the first term, we can use this formula to figure out the nth term. That's t sub n. So it's just going to be your first term plus the common difference times whatever term you're looking for minus 1. Like when we were looking for the 10th term on that warm-up, we used 10 minus 1, or 9, as the thing that we were multiplying by that common difference of 3. Now, if we know the kth term, not the first term necessarily, we can use this modified formula. It looks almost the same, but now we're starting with our kth term, and we're adding the common difference times n minus whatever k is. So it's really the same as this first one, but instead of 1, we use k in all those different places. So our first example, we want to find a formula for t sub n, in other words, the nth term. And we're given the sequence 8, 6, 4, 2. Pause the video and see how far you can get on this one. So a good way to start this would be to write the general formula for the nth term. Now, since we have the first term, we can use t1 plus d times n minus 1. If they started us somewhere in the middle of the sequence, we could use that other formula. So we know t1, and we're going to have to find that along with the common difference, d, in order to plug things into this formula. So t1, that's just our first term, 8. The common difference is just what you have to add each time to get to the next term. So to figure this out, you can just take one of the terms and subtract the term right before it. It doesn't matter which 2 terms you use as long as one comes right after the other. So we could do 6 minus 8 to get negative 2. So this time we're subtracting 2 each time. Or you could have done 2 minus 4, 4 minus 6. Doesn't really matter, because the whole idea with the sequence is you keep doing the same thing to get the next number. So now that we have that, let's go ahead and plug it all in. We can say Tn equals 8 minus 2 times n minus 1. And we're just going to clean this up a little bit, distribute and combine like terms. So that's 8 minus 2n plus 2, which is to say 10 minus 2n. For the next example, they're giving us the first 2 terms, and they want the 101st term of this arithmetic sequence. Now, it's very important that they told us this was an arithmetic sequence, because otherwise, just with two terms, we wouldn't know what was actually happening. I mean, sure, one way to get from here to here is to subtract 6, and maybe that's what we keep doing the next 99 times. But, I mean, how do we know for sure if they don't tell us? Maybe there was something we multiplied 76 by to get 70. So this is a very big key word here. So now that we know it's an arithmetic, we can write down that general formula, t1 plus d times n minus 1. This is what we did when we were finding an equation for the nth term, only this time, in addition to finding and plugging in t1 and d, we also need to plug in n to actually figure out the nth term. So for this one, t1, they gave that to us. It literally says t1 here, so it's just 76. The difference, we can do 70 minus 76 to find our common difference, and that's going to be another negative number this time, negative 6. So we're going to be plugging in 76 minus 6 times, well, we want the 101st term, so that's going to be 101 for n minus 1. So that's 101 minus 1, which is 100. So minus 600, and that's going to come out to negative 524. We're going to wrap this lesson up with a real-life arithmetic sequence. Let's say you give the psychic hotline a call to see what the future holds for you. To prove her authenticity, the psychic who handles your call predicts that your bill will be $25 after 8 minutes and $61 after 20 minutes. That's definitely looking into the future. If this prophecy comes to pass and the bill increases by the same amount for every minute after the first, we want to know what was the cost of that very first minute. So basically, we're being given two terms here. 8 minutes, the cost was $25. So we could say that T8, the 8th term, is 25. And we could also say the 20th term, T20, is 61. Now, they wanted the first minute, so that means we're asking for the value of T1, the very first term. So here's that psychic hotline problem officially stated. Now, there's a few things working against us. We don't know T1. We're actually trying to figure it out, although we're not always necessarily looking for T1. Either way, we have to use the general formula since we don't have T1. So that would be Tn equals Tk plus d times n minus k. Next, they didn't actually tell us what the difference was, and since they didn't give us two terms right next to each other, we can't, for example, just do 61 minus 25 and assume that that's the common difference. But what we can do, since these follow a linear pattern, that means that your common difference is basically the slope. So we're going to find the slope, and that's going to be our common difference. So the y values we have to work with here, 61 minus 25, and for our x values, we've got 20 minus 8. So that's going to be 36 over 12, which is 3. So d is 3. And now we need to figure out what we're plugging in for all these other things. N is going to be 1. You're just plugging in 1 because you want the first term. But how about tk and k? Well, tk can be any term in the sequence. It doesn't have to be the first term. It could be, but it usually isn't. So they gave us two different terms here. They gave us the 8th term and the 20th term. You can use either of these for tk. But the one that you choose, 25 or 61, that's going to determine what your k value is. If, for example, we choose 25, then that means we're committing to have a k value, an index of 8. So we could say 25 plus 3 times n minus 8 equals t of n. Or you could say 61 plus 3 times n minus 20 equals t of n. So just pick one and be consistent. Now again, our n value is going to be 1 because we're looking for the first term. So just plug 1 in there and let's see what we get. So let's see, this is going to be negative 7. 3 times negative 7 is negative 21. 25 plus negative 21 gives us 4. So that means that first minute of this call was $4, and it was $3 for each additional minute. Let's talk about arithmetic series now. What is an arithmetic series? Well, you know what an arithmetic sequence is. It's just a bunch of terms with a common difference. An arithmetic series is just the sum of an arithmetic sequence. So we have the sum of n terms here. We have term 1, and then the next term is just going to be whatever term 1 was plus a common difference. The next term is another common difference added. So it's just basically a bunch of terms like 3, 6, 9, 12, 15, but instead of putting commas between them, we're adding them all together. So there is a short way to do this. I mean, you could do it this way and list them all out and add them, but what if you have like 1,000 of these things? So a faster way to do this, we're going to do a little bit of kind of theory proving here. Let's say that I take this same list of terms and I reverse the order of them. So I still have the sum of a certain number of items, but I've also now reversed their order so that the last item, Tn, is now the first item. And then the second to last item, Tn minus D, is now the second item, and so on and so forth. If I take this list and I add it to the first list, which is identical, it's just a different order, well, on the left side, now I have 2 times whatever the original sum was. On the right side, look what's going to happen here. T plus T1 plus Tn is just going to be T1 plus Tn, but in the next set here, these D's are going to cancel. And so are the 2 D's. And so are the minus D and the D over here, and all the D's in between. So that I really just have T1 plus Tn plus another T1 plus Tn plus another T1 plus Tn all the way till the end of the list. So we have 2Sn on the left and a whole bunch of these T1 plus Tn's on the right side. How many of these T1 plus Tn's do I have exactly? Oh, well, this is a list of n items, so there's n of them. So instead of taking n of these things and adding them together, I could just multiply one of these things by n. All right, we're almost there. If I just want to find the sum of one of these lists, I just divide the whole thing by 2 here. So we get our sum of an arithmetic series formula. Sum equals the number of items times the first item plus the last item, all divided by 2. Now, another way you could think about this is you're really just averaging the first and the last item together, adding them together and dividing by 2, and then you're multiplying by the number of terms. Let's take that formula for a test drive. So they want us to find the sum of the first 200 items of a series that starts with 18 and ends with 472. Now, if you didn't have this formula, just contemplate for a sec how difficult this would be. You couldn't even add anything together if you didn't know what the common difference was. So you'd have to find the common difference and then add 200 things together. Or you could just plug things into this formula. Take your pick, right? What's n? 200. There's 200 items. T1, well, they gave you that. It was 18. Tn, that's just the last term, 472. And then it's all getting divided by 2. So let's just plug that into the calculator now. So crunching those numbers, we end up with 49,000. Wow, that's way faster. For our next example, we're going to find the sum of another arithmetic series with slightly different information. So we want the first 25 terms added together of this series right here. Pause the video and see how far you can get on this one. All right, so I always start by writing the sum formula. So again, n times a1 plus an over 2, because this basically gives me my shopping list of everything I need to find before I can get the answer. So what do I have? Well, n, that's going to be 25. They gave us that. A sub 1, that's our first term. That's this 17 here. We also know that. A sub n, that's our last term. That would be our 25th term, which they did not give us. We got a ... out of them. So we need to figure out a sub n first before we can use this original formula here. So how can we do that? If only there were a way of figuring out the nth term of an arithmetic sequence. Well, actually there is. Pause the video and go back to example 1 if you forgot it. Yep, it's this formula here. We have a1 plus d times n minus 1. So in order to use this, we need to know the first term, which we know. It's 17, so we're looking for the 25th term now. So we have 17 plus, what's our common difference here? Well, we have 2 terms that are next to each other. We can just subtract here. 25 minus 17 is 8, so positive 8. And then, what's the n value? Well, we want the 25th term eventually. So we're going to do 25 minus 1. And then let's do this on the calculator. So if I plug that in, I get a 25th term of 209. And now I have everything I need to use the sum formula here. So I can go back now and plug everything in. We have the sum of the 25th terms equaling 25 times 17 plus 209 over 2. All of this. And let's pause the video and use the calculator on this one. So here I go, plugging it in my calculator, and I just did alpha y equals to get my fancy fraction format here, so I don't have to worry about PEMDAS and parentheses and all that. So that comes out to 2,825. We're going to do one more arithmetic series example. Pause the video and see if you can strategize what you need to do on this one. Okay, so again, I've got my formula here, n times a1 plus an over 2, and I've got a1. That's the first term, that's 3. This time around, they actually gave me the last term. I don't know what n is, but I know that a sub n is going to be 139. That's my last term. But here's the problem now. I don't know what n is. So I need to figure out how many terms I actually have in this series before I can use my formula. So how could we do that? Well, we again go back to our nth term formula. An equals a1 plus d times n minus 1. This is actually a very flexible formula. We've been using it to find the nth term so far. But in fact, there are 4 different parameters, different variables in this formula. If you know any 3 of those variables, you can find a fourth missing variable. In this case, we're missing n. So if we know a sub n, a sub 1, and d, we can figure out n based off of that information. What's a sub n? It's 139. They gave that to us. First term, a1, that was 3. And what's our common difference? Well, 7 minus 3 is 4. So we can write 139 equals 3 plus 4 times n minus 1. And now since n's the only variable, we can actually work backwards and figure out how many terms have to be in this sequence. So distributing here, I've got 4n minus 4. And I'm also going to subtract 3, so that's 136 on the other side. Adding 4, I've got 140, and then dividing by 4 to get n by itself. Let me just do that on the calculator. So 140 over 4 is 35. So I have 35 terms to work with here. Now I have enough information to plug it in my original formula. Feel free to pause the video and do the honors there. All right, so I've got 35 times 3 plus 139 all over 2. Calculator time. And let's see what this comes out to. 2,485. So that's it for arithmetic sequences and series. Hopefully you had some fun on this one. Until next time, Mr. Sutton signing off.